Hi. Yeah, it's working. Yes, I'm very happy to be here in Lille. It has been like 10 years, so I'm very glad to make it. So I'm here to talk about the real-time auction, the real-time bidding that we do at scale in Criteo. My name is Irene Caroulle. I am the dev lead of the RTB team and the efficiency team in Criteo. RTB stands for the real-time bidder. And who knows about Criteo in the audience? Wow, quite a few. Oh. And who knows about AdBlock Plus? Many more, of course. So yeah, we are doing advertisement retargeting, and we are doing it at scale. So to illustrate this, you are going to a merchant website, you are looking for shoes, and a little time after, you go to your favorite news website, and you see an advertisement for shoes of different color, for socks. That's what we do. We are displaying the best product to a user. So let me tell you about the advertising landscape, how it is. So the keyword here is inventory. Inventory is the available space on a web page, and we have the entity that possesses it. We are calling them the publisher, either web or apps. And there is, on the other end of the spectrum, the buyer, Criteo and its competitor. So those who possess the inventory try to monetize it. And in between them and the buyer and Criteo, we have the SSP, the one that are supplying the inventory to us. And the mightiest of all, Google. So when I speak about the RTB or RTB application, this is the thing that we do in the Criteo side. The application that is giving back to the SSP a banner at a certain price. And this is the SSP that will hold the auction. Everything happens in real time, in a few milliseconds. There is a trend in the industry which is to remove that third party, which is a SSP, and have the publisher and Criteo more close together and directly doing the auction. So here is the Criteo big number. So we have 200 billion of requests a day, and this is freaking huge. It's at peak 5 million requests a second, and it's still growing. And we are managing our own data center. We have more than 3,000 machines spread across the world. We have 2 data centers in Europe, 2 data centers in America, 2 data centers in Asia, and we are managing everything ourselves. We are connected with many SSPs, 60, yeah. And the traffic we receive is 80% bids, and we also receive post-bid notifications that are telling us if we win or why we lose. We are replying to those bid requests in 10 milliseconds on average. The SSP is giving us a budget of 100 milliseconds. And the time it takes for us to reply depends on the inventory type. And we have a very high participation rate. 40% of the traffic we receive, we will reply, yes, I want to bid on that. And this is very big because we are able to tell our partner, to tell our SSP that this user, we think it's profitable or not. So we can filter the traffic on the hand. And 1% of CTR, it's the figure that it means that when you display her ad, there is 1% chance that a user click on it. It's much better than the competition. So here is the stack we use. It's, I would say, pretty classical. For the real-time stack, we are writing a real-time application. We have a .NET stack and a JVM stack. And we are using C# and Microsoft IIS for the .NET things, and Scala and Mesos for the JVM part. Who is familiar with Scala among you? Yeah, quite a few. Nice. We should talk after that. So there is a project ongoing in the R&D department of Criteo to move to .NET Core, and thus allow to run C# application on Linux, on Mesos. For data, we are heavy user of Memcache, Couchbase, SQL Server, and everything that is stream processing will go through Kafka. So what the RTB application is doing, the application my team is in charge. So first, we are decoding a protocol. All of those SSP are speaking with us through a dedicated protocol. So there is a part of our application that is dedicated to that. We do it in C#, but we also develop our own DSL to do it more efficiently, because it's really time-consuming. And we want to free the engineering time of doing this integration. We want the R&D to focus on more important things. So by using a DSL, it was a good move because we have been able to externalize that integration part from the core RTB team. The second step we do in the application is to load the user data. And what is a user data? Well, it's an event that is emitted on the merchant website. We receive 7 billion of them every day. So every time you put a product in the basket, or you search on a website, on a merchant website, or you look at a product, or you buy something, there will be an event that we will receive. And we are loading this in a layer that is in a multiple layer architecture. We have memcache that holds some data we can access in a millisecond. And if there is a cache miss, we will go through Couchbase, which is used for the persistence of all the user data. And there is also an interesting thing, which is a cross-DC update. Every time we have to update the user data, we write in the 2DC of a particular region, for instance, Amsterdam and France, because the SSP can at any time rebalance the traffic to France or to Amsterdam, and we want to have the data as fresh as possible. The third big thing is the arbitrage. It's all about selecting the campaign, and this is where we are using, I would say, the F the X of the machine learning. So with the context of the request, we will be able to select a campaign and determine a price. And at this point, we have the publisher and we have the advertiser which propose product. So we can do a blacklisting there between the one that does not want to work together. For instance, you does not want to have a news advertisement for Le Figaro on the Le Monde webpage. And we are also doing the rendering in real time. So we can compose the banner and select the best product of the campaign. And there is a kind of inventory that we call native, and which is trying to integrate better into the website. And we are able to see what will be the best layout of a banner that will perform the best for that particular context. And the last thing is that we are emitting a lot of business log. It's 100 terabytes a day. Every bid or no bid log will be emitted into HDFS. I think it's the biggest cluster in Europe. And this is used for feeding the machine learning, but also for analysis. So all of this is services that we are using. So we are only the portal, the entry point of all the traffic in Criteo, and we are using arbitrage service, render service, and everything. So we are doing actually filtering, and this is key in our role to be very efficient in filtering. So there is multiple kind of filtering. You have the static filtering, which is cheap, but brings you a small saving. You have the dynamic filtering, which is more complex to introduce. It is context-aware, it is user-centric, but it will remove a lot of candidates. And we also have that traffic filtering thing. I said that we can tell the SSP that we don't want that user, or we really want that user. And this is free for us, because if a user is not profitable, we will not get the traffic. And the thing is that it's mostly web-based, not very used for in-app. So I hope that you can see that trend. Yep, it's 1 year in the life of Criteo, I would say. So we have the number of requests per second. Last year it was 1.2, and now it's 2.5, something like this. So it's booming, really. And there is 2 reasons for that. First, the in-app traffic is getting bigger and bigger every year. So there is a trend, a shift from the browser to the mobile. And we do not filter that traffic. The SSP not always provide that capability. And there is also another problem, which is we receive multiple requests for the same opportunity. The configuration on the publisher side and on the real-time bidding, let's say, workflow is so complex now that we can get called multiple times for the same opportunity. And we have also a buyer of the inventory that can resell to the other, and so on and so on. So sometimes we are receiving the request from one of our competitors. So about the let's say, tactical optimization you can do. When you are using a managed language, just think about your garbage collection time. For instance, on the .NET, there is that stop of the world thing where every thread stops and you're collecting, and it can be very, very hard for you. And there is also that large object thing. So large object, more than 80K, will be long to allocate, long to free, and will cause fragmentation. So think about that. On the CPU side, of course, make the best use of your cache, data locality, and think a lot about your threading models. For instance, the C# is offering async await keyword, but it's not always the best use of your threading resources. And on I/O, I would say don't really bother to introduce throttling in your application. Just use stream processing such as Kafka to make multiple services communicate. And at this scale, you should think about using a binary protocol. So pick whatever you want, just not JSON because it's longer to serialize and cause a lot of allocation. So if you walk around the office in Criteo, wonderful office between Lafayette and Montmartre, you will see this on the R&D floor. It's everywhere, application monitoring everywhere. So I would say there is two schools in the monitoring. We have the red box, green box school. So the ones that like to see immediately what's going on, and we have also the ones that are relying on curves. They prefer to see curves, and the monitoring comes in all sizes and shapes. So there is still a framework we use in Criteo for the monitoring. There is an architecture which is having a monitoring board for the worldwide monitoring. And then when you want to go deeper into DC, you have the DC level monitoring and then the machine level monitoring. I would say that every team does that. And there is also a member of the team, the Moab guy, but I should say the Moab person that is dedicated to looking at those boards. And this is one of the boards for the business. So you can see 24 hours in the life of Criteo, the traffic going down during the night, going up in the morning, and the different metrics about the number of clicks, the number of display, and everything. And we can compare with the previous day between the green line and the yellow line. So it's also very important to be extremely efficient in terms of application deployment. So the programmer, the Moab person actually is in charge of selecting a candidate version. And the first step, the really first step, is to try that version into one machine in every DC. This is a test deploy phase. And once we get a version validated, we enter that workflow. So first step, Canary. There is 5% of the traffic that is dedicated for Canary, and it is prod traffic. Yeah. Canary are always talking to Canary. It's an end-to-end thing. And we have a dedicated pool of user data to not break everything if something goes wrong. And once these get validated, we enter the second step, which is a platform deployment. Think about a continent. We usually pick the US DCs because at the time in Paris, where the R&D is, we woke up, we want to move forward with the deployment, and there in the US, they are still sleeping. So there is a low traffic, we will not break things big time. And when it's validated, it's, again, the remaining machine. So it's a 3-step deployment, and it takes 3.5 days. It means that that application RTB that is getting 80% of the traffic of Criteo, that is probably doing 70% of the business, is deployed twice a week. And this is a collaboration between the escalation team and the R&D team. The escalation team is the other one that are responsible of the deployment. And really, they are very helpful to automate things and to facilitate things. So there is still a lot of human intervention in the deployment, but they are working on making it doable through Slack bot and everything. Yeah, so with that team in a backup, responsible for doing the release, stopping the release, you can think about like a SWAT team. You always have someone in your back, and they are fast to roll out, but they are even faster to roll back in case of problem. So with that scale, architecture optimization is key, and it's a cost-driven approach to optimization. It's easy to get many machines, so providing a better code with optimizing a specific loop will not help at the cluster level, really. So when you are managing your own data center, you need to be more strategic with that. We have people in the finance that are working on telling us how it costs for 1 million of requests. And the further down you go to that pipeline, decoding, arbitrage, under, the more the 1 million of requests will cost. So what you can do is to introduce a service in front of the RTB to eliminate most of the requests. And even if you introduce 1 millisecond of latency, the overall cost of this infrastructure will be less, because that application will filter, will be dedicated to filtering, and this will help the RTB to receive only the valid traffic and scale at a much slower pace. And we are also trying to break the monolith and pushing everything into service, but not really in a microservice approach. So traffic shipping as a service, think about an appliance, something that you can put in front of your application or remove at any time. And we call that application sifter. So this is software-based. You can see on the architecture that we have F5 load balancer. We cannot really program them. They are it's difficult to program them. The language is, I think, TCL/TK, something like this. And it's when you start to put some logic in it, the performance will drop dramatically. So you basically need something made of software. And this is the sifter project there in the middle. So it's dedicated to filter at a very low cost. Actually, the team FNC stands for fast and cheap, or fish and chips, whatever you want. But they are producing an application that can get the same amount of traffic, but at 40 times cheaper. And we have streamlined the feature at max to get that performance. And so minimum decoding capabilities, static filtering, and routing the traffic to other services if we need. So here, really, the goal is to have that application in front of RTB just after the LB to filter the most out the unnecessary traffic, and at the cost that is much less. Then this way, you will be able to scale your pool of RTB more slowly and scale that filtering part independently. Also, about services, there is some rules we try to do in Criteo. So an application should handle one type of traffic. As I said, the RTB application today is handling the bid request and also the post-bid notification. We will break this because there is no need to have the same level of criticity, the same level of real-timeness for both traffic. And yes, really think hard about extracting the critical path. Everything that is not directly related to the bit request processing is something that we can remove. And if you want to do that in your application, I would recommend you to start to isolate the code in other thread. You can have a queue and workers and consumer to make this processing separate of the rest. And then it would be much easier for you to move it as a service. Also, we use and transform monolith into service when there is a consolidation into some area. For instance, on the user loading, user identification, it has been extremely active recently. So we split that into another part to give it to another team. And also a few rules you can check before splitting into service, and you want to work with the other team. So defining a protocol, of course, defining the SLA, the time it takes for you to respond, and the level of service, I mean, the availability. Also provide the monitoring and make sure that you provide client and also mock client if they want to test. And for instance, if you are doing multiple language like Scala and C#, you need to provide at some point a mock service, not only a mock client code. So, well, I would say other benefits of SOA is code ownership, a better collaboration, because it was really hard for the RTB team to have 6 other teams pushing code into our repo, and we were not really owner of that. So it was long to review, we had a lot of questions, so just splitting a service can help you to collaborate better with the other team. And I would say also it helps us to move faster. There is a lot of opportunities, some other will say threats in the ad tech industry, GDPR, fraud, traffic increase, other bidding, and we have competitors and other companies that just collapse when they cannot move fast, when they cannot release fast and deploy fast. So really think about this. It helps a lot to move faster. So wrapping everything up, RTB is all about making filtering super efficient, and we are trying to put the filtering in the best place. Sometimes it can be in another service, just right after the LB. And infrastructure cost optimization is our priority. We are trying to save the resources of a cluster and not necessarily the resources of a single machine. And team and architecture agility will unlock fast development. And I really think that the first word is team. So that is working with people, right? You want a very good team agility, like the one we have, this escalation for the deployment, or the one we have with the Tetris team for the integration with the SSP. And this is key for success and to move fast. And I think that's it. Thank you very much. And now if you have questions. Sometimes the first question is hard, so maybe the second one. Nope. Oh, cool. Yeah, thank you.
Yeah, thanks for the talk. I think I heard that you're doing some cross data center data storage that comes into one data center and you're replicating to other data centers. Do I understand that correctly?
Yep.
What, is there a particular database technology or protocol, or also kind of what SLA do you look for when you're doing that, solving that pattern?
So the question is, do we have some kind of sorry?
So are you doing that with a particular type of database, like a Cassandra or protocol data store? And then what kind of SLAs do you look for when you're doing that cross data center replication? Like how fast?
Yeah, I would say that I don't really know the detail, but it's not that paramount to have it working, because it's only when the user will switch from a DC to another. So we don't the user data is restricted to a particular region, and we are doing this to maximize our to maximize the profit we can take by serving a better ad if there is a switch of traffic coming from an SSP. And if we see that a particular user in different regions, which is pretty rare, actually, we will be able to serve a better ad for him. But I don't really know the details, sorry.
Another question? Okay.
What are the challenges you had to face with the GDPR?
So I cannot go into the detail for that, but my team was responsible in implementing the rules that filter the traffic under the GDPR constraint. And actually, the reference implementation for GDPR came very, very late, like 1 month before the limit date, which was the 25 of last month. So it was hard work and hard time to include those rules into the code and make it work very, very fast. We have to do this very quick, so we had a couple of extra hours, but we made it, actually, 1 day before. And the thing is that the recommendation we get from the product team, they were discussing with the legal and everything. It was a conversation at a very high level in the company, and we receive information very raw, very, very, very directly. And it was a challenge to take that always changing, everyday changing recommendation and transform them into the code and deploy.
Might have one question myself.
Sure.
You've been talking about like splitting code to services to scale. I know it's something which is often misunderstood, and some teams, small teams in startups, which are absolutely not at critical scale, just to follow a trend, start to split the app into microservices. I would ask, what would be your advice to avoid premature optimization, and at which point you would recommend to start having this approach?
Oh.
Tough one.
Yeah. Well, as I said, for instance, for the user identification part, the problem is when you have multiple teams working on the same code base, it's very difficult. It slows down everyone when you have the owner of the repo to do all the review. So at some point, it's just you can decide to lose a bit of performance to win in agility, and it doesn't matter if you lose 1 or 2 milliseconds if you get time to the market 10% faster. So that will be maybe the main driver there.
Okay, so for smaller teams, like practicity in code organization rather than raw performance, you would say?
Maybe, yeah.
Okay, thank you.
Thank you.
Thank you
very much.